Hello. Welcome back to another video on the Blackboard. Again, we're going to continue on with linear transformation. And as I mentioned in our previous video, we're going to be practicing the same types of questions. The only difference is that these are a little bit more harder, so require a little bit more work, but it's not something that you have to um learn because you've done this type of work before. It's just now we're going to put it into this concept and let's get right into it. So it's pretty much the similar questions that we had the last example. So we're going to let the function t, go from R3 to R3 and have it be a linear transformation such that t of 1, 1, 1 is equal to 2, 0, negative 1. T of 0, negative 1, 2 is equal to negative 3, 2, negative 1. And then t of 1, 0, 1 is equal to 1, 1, 0. So now we have to find these four functions, or I guess four outputs, given the input being the t210. So in our last video, we were able to quickly solve these by just plugging in our k. Well, we to solve these types of questions, we were able to exploit the fact that this is a linear transformation. So we use the fact that this was closed under addition. So remember that t of a plus b is equal to t of a plus t of b. And then closed under scalar multiplication. So t of ka is equal to k t of a. And so in our last video, we were just able to use these, exploit the fact that, and also the fact that the inputs that they gave us was 1, 0, 0, 0, 1, 0, and then 0, 0, 1. So all we really had to do is find our k, which was the same as what we were given. So if it was, in this example, our k's would be 2, 1s, and 0, and then add them all together. This case, in this example, you have to do the same thing. You will pretty much do the same thing. The only difference is our k's will not be known. We have to find them first. So in our previous example, they were already given. In this one, it's not going to be 2, 1, and it's not going to be 2, 1, and 0. No, we have to find them because the inputs that we were, or what we were given, are not gonna cooperate. So how we're gonna do this? Well, we gotta use matrices. Well, I mean, you can use matrices. You can also do systems of equations, but we are going to do matrices to solve these. More specifically, put this in an augmented matrix. And if you remember an augmented matrix, you have a matrix on one side, and on another side, we either have a matrix or a column vector. So now the next question is, what's going to be in the augmented matrix? Well, it is simply going to be our inputs that we were given. So our 1, 1, 1, our 0, negative 1, 2, and our negative 3, 2, 1. And we're gonna put these all in column form. So this would be 1, 1, 1, 0, negative 1, 2, and then negative 3, 2, negative 1. And on the other side is what we are trying to find. So it'll be 2, 1, 0. And what we have to do now is put this in row reduced echelon form. When we do that, we get our k values that we have to multiply on each function that we were given, add them all together, and there goes our answer. So like I mentioned, this isn't anything new. It's just, just a little bit more work, but I am going to show you two ways, the long way and then the, I guess, shorter way. It's not really short, but like you write less. But it's something that you have to like keep track of, or else you might make a mistake. So let's get started with putting this in row reduced echelon form. So what I'm gonna do is, well, I am going to cancel out these ones. So it's going to be R2 minus R1 and then R3 minus R1. And that will give us the first row being untouched. The second one will be 0, -1, and then this would be 2 2 plus 3, 1 minus 1, -1, 0. Oh no, 2 minus -3, 5, and then 0, 2, then -1 minus -3, so -1 plus 3 is 2, and 2, 1 minus, no, not 1 minus, yeah, 1 minus 2 is -1, and then this would be -2. Okay, hold up. Time out. I realized I wrote this wrong. I wrote this part wrong because we're not supposed to take this one. It is the other one. This one. 1, 0, 1. Okay, 1, 0, 1. We're still gonna do the same thing, cancel out the ones. 1. Okay. Now this would be 1. First one remains untouched. This goes to 0, 1 minus 0, then 0 minus 1, -1, and then this would be 0, 2, and then this would also be 0, so this would be 1 minus 2 is -1, and then the other one will be 0 minus 2 is -2. Okay, that one looks much more better. Alright, there you go. So now the next thing that we're gonna do is get rid of this 2, and that is simple as R3 plus R, not plus R, plus 2 times R2. And again, first row remains untouched. Second one now also remains untouched. And the third one, this would be 0. This would be 0. And then -1 times 2 is -2. Then on the right side is -2, -1. And then we have -2 plus 2 times -2. So it'll be -2 minus -2. No, -2 minus 2, which would be -4. And then now what we can do is divide this part by 2. And then multiply this part by -1. So I'm gonna have -R2 and then 1/2 R3. I mean, we could do -1/2. That could work. But the reason why I'm not going to is, well, you'll see in like the next step. So the top part remains unchanged. This becomes positive. This becomes, where did that one come from? This becomes halved, -1, and then this remains unchanged, positive, half. And so now what we can do is we can add row 3 to these two to cancel them out. So it will be, and then multiply this by -1. So our first step is going to be R1 plus R3, and then our second step R1 plus R2, and then our last, well, not R1, not R1, R2 plus R3, there we go, and then -R3. So it's going to be top to bottom. That is going to be our steps. And I think I can make them fit. So we will have on our left side the identity matrix. The right side will be our answer. So 2 minus 2, 0. 1 minus 2, -1. And then this becomes positive because it's negative. And that is our k's. So this will be the constant to multiply for the T111. This one will be, I guess let me just use a different color. This -1 would be for the T0 -2 over here on the left side. And then this 2 would be for our last T, the T100. So all we have to do is just these are our k values. So now we have to multiply those by the function. So T of 210 is going to equal to what's that thing called? 0 negative T of 0 -1 2 plus 2 times T of 101. Substitute those in, and we have -3 to -1 plus 2 times 110, and that is equal to 3 -2 1 plus 2 2 0, which will give us the final answer. 3 plus 2 is 5, 2 minus 2 is 0, and then 1 plus 0 is 1. And that is our final answer. So that was a little bit of work. So now let's get started. Now let me show you like a shorter way to do this. And this only works if you still have the same linear transformation, the same givens. So to do the shorter way, unfortunately, it only works after they give you a once they ask you to find more than one output, because you need to do it the long way the first time around. The second time around is what happens is to find these k values, our k's for this, you have to put it again in augmented matrix and then put it in row reduced echelon form. However, the steps to take will always be the same as the previous example. So all we really have to do is just write what's on the right side of the augmented matrix and then do the steps that we did. So it is important that you write these steps and then do them in the order that you did them on the previous example. So we can go from left to right. So what this ends up being is we subtract 2 to 1 and then 3 to 1. So this would be 1 minus 2. Well, the top one stays the same. This would be 1 minus 2 is -1, and then whoops. This is not right. This is not right. This is not right. It is not these. It is 2 -1 1. Okay. Now we do 2 minus 1. So it'll be -1. Well, top one stays the same. -1 minus 2 is -3, and then 1 minus 2 is -1. Cool. Now the next one is we multiply the third row to the second row, or twice the second row. So this first two remains the same, and then this would be -1 plus 2 times -3, which would be -6. So we have -1 minus 6, which would be -7. And then we take the negative of the second one and half the third one. So this would be 3, and then this would be 7 halves. And then lastly, we add the, oh, this will be -7 halves. We add the first row and the second row by the third row, and then take the negative of the third. So this would be 7 halves minus 2. So this would be 7 minus 4, which would be -7. -7 plus 4, which would be -3 halves. And then this would be 6 minus 7, which would be negative 1/2, and then this would be its negative, so negative 7/2. So this is our k value, and then all we have to do is just plug it back in. So this would be negative 3/2 of t111 minus 1/2 t of, what was the other one? 0, negative 1, 2, plus 7/2 t of 1, 0, 1. And then you substitute those in, which would be negative 3/2. I forgot what the ones is equal to. 2, 0, 1. So 2, 0, negative 1 minus 1/2. Negative 3, 2, negative 1 plus 7/2 of, what is it, 1, 1, 0? 1, 1, 0. And this would be negative 3, 0, 3/2 plus 3/2, negative 1, 1/2 plus 7/2, 7/2, 0. So now we have, this is equal to negative 3, well, actually, no. Let's do the 3/2 plus 7/2, so 3 plus 7 is 10, over 2 is 5, minus 3, this would be 2, then the second one would be 0, minus 1, plus 7/2, so this would be 7 minus 2, which is 5, divided by 2, 5/2, and the last one would be 3/2 plus 1/2, which would be 4/2, which is 2. And that is our final answer. And so this method, you still have to do like kind of the same amount of work, but you write less. But make sure you double check with your professors or teachers, because they might not give you full credit because they probably want you to show all your work. But this is a much more shorter method, and we can just go ahead and do this to continue our last two examples. Oh my, I'm almost 17 minutes. I don't know if I should stop it here. No, okay, you know what, I'm gonna keep going. Try to be as quick as I can. So the next one is, again, use the same shorter method, 2, negative 1. You subtract from the first row, but because it's 0, you don't do anything. And then you add twice the second row to the third row. So this would be negative 1 plus 4, which is 3. Halved 1, the other one becomes negative, so this becomes negative, and then this becomes 3/2. And then you add the third to the first and the other one, and you take the negative of the third. So this would be 3/2, this would be negative 3/2, and this would be 3 minus 4, negative 1/2. This is our k values, and now we're going to substitute it in. I'm going to skip this step and then go straight into the other one. So this would be 3/2, 2, 0, negative 1, minus 1/2, negative 3, 2, negative 1, minus 3/2 of 1, 1, 0. This is going to be equal to 3, 0, negative 3/2 plus 3/2, negative 1, 1/2, minus, not minus, plus negative 3/2, negative 3/2, 0. Combined them all together, so we have 3/2 minus 3/2 is 0, so we're left with 3. 0 minus 1 minus 3/2, so we have negative 5/2. And then 3/2, negative 3/2 plus 1/2, it is negative 1. So that's the answer to the 7th one. And then our last one, again, the same thing, the short method, negative 2, 1, 0, subtract row 2 and row 3 by row 1. So this would be negative 0. This would be negative 2. Bottom will be negative 2, and we have 1 minus 2, 3. If I am correct, if I do know how to add, then we add the third row by twice the second row. So negative 2, 3. 3 times 2 is 6. Minus 2, it is... Wait. 3 times 2 is 6. 3 times 2 is 6? Yeah, 3 times 2 is 6. Minus 3 times 2 is 6. Minus 2 is 4. Take the half and then negative. So it would be negative 2, negative 3, 2. And so, oh, no. This is wrong. Negative 2. So it'll be 0 minus negative 2. So that would be 2. So this would be 2. And then 6 plus 2 is 8. Half this one should be 4. Wow, you really can't add. And then, so we subtracted, added, half, negative, and now we add. Okay. So this would be 2, this would be 1, and then this would be its negative. So this is our k's. So this would be equal to, don't memorize them. I didn't memorize them. 2 times 2, 0, negative 1, plus negative 3, 2, negative 1. Oh, we don't have to work with fractions. Beautiful. Negative 4 times 1, 1, 0. This would be 4, 0, negative 2, plus negative 3, 2, negative 1, plus negative 4, 0, which is 4 minus 4 is 0, minus 3 is negative 3, 0 plus 2 is 2, minus 4 is negative 2, and then negative 2 minus 1, it is negative 3. And that should be our answer to the last one. And that is all for this video. I went over 20 minutes, but hopefully you were able to do this and understand how we do it, as well as do the shorter method if you can do it, and you have to check with your teachers. And wow, these last two examples we went kind of quick, which is pretty good in my opinion, because that should be like the amount of time it should take you to do it, because for some reason there's this thing called a test that you're timed. I don't know why they do that, but that is all for this video. I don't think we have anything else to do for this chapter. I could be wrong, but if you'll find out next video if it's going to be a lecture or another example. So until next time, I'll let you guys go. We're over 20 minutes. Oh my gosh, that was so long. And I'll see you guys in the next video. So take care, guys. Bye. And gals. Bye.